Today we're writing quadratic equations. We've already written linear equations a chapter ago, and now we're going to write quadratic equations. You'll remember from linear equations that we had three different forms. Do you remember what standard form was for a linear equation? Right, it was ax plus by equals c. Quadratic equations also have a standard form, y equals ax squared plus bx plus c. It's the form we use when we solve by factoring. This is kind of a reveal here. I don't think we've mentioned before that there is a formula for axis of symmetry that comes from standard form. It's negative b over 2a, and that gives you the x coordinate of the vertex, right, which is also the axis of symmetry, and then you can plug that x coordinate into the equation to find the y coordinate. So we're going to practice that in a bit. Then we're going to do vertex form and just relating it to lines. In a linear equation, this would be akin to like our y equals mx plus b form, right? That was the form that made it easy to graph the line, and vertex form makes it easy to graph the parabola because you have the vertex, right? The main thing. And then in intercept form, that's one that helps us find the roots. This would kind of be like point slope form for us. Remember point slope form, x2 minus x1. It's not like very popular, right? And we were like, oh yeah, there's that one too. That's kind of what intercept form is. Oh yeah, there's that one too. So first let's talk about this standard form and the axis of symmetry. So we're going to use the formula here to find the vertex and axis of symmetry. The formula is negative b over 2a. Or the negative of negative 10 is 10 over 2 times negative 1, or negative 5. So this negative 5 gives us the x coordinate of the vertex, and it also gives us the axis of symmetry. To find the y coordinate, do you know what we're going to do? Yep, we're going to plug it in. So y is equal to the negative 5 squared minus 10 times 5 plus 10. And if we solve that, we're going to get 35. For sake of room, I'm not going to show you the other way. I'll do that in the notes in class, but if we did it by changing the form, we would get the same vertex. If we did it on the calculator, we would get the same vertex. Trying it one more time here, the vertex is negative b, so the negative of negative 4 would be 4 over 2a, so that's 1. So that means that the x coordinate of the vertex is 1, the axis of symmetry is 1, and if I want to find the y coordinate, I would plug it in, right? 2 times 1 squared minus 4 times 1 plus 1, and that's going to end up being negative 1. So it's actually a pretty nice little formula there, negative b over 2a. They use that formula a lot in pre-calc next year. Okay, so now they're going to give us a graph, or just basically the information of the roots and a point, and now we're going to use for the first time intercept form. So here I see that the roots are negative 3 and the root is 2. Right? So intercept form tells me this is going to be a times x plus 3 and y minus 2. Oh, sorry, x plus 3 and x minus 2. This sounds familiar, right? This is just going from the roots to the equation. The difference is now we know the vertex. Before we didn't. So now we know, or not the vertex, but now we know another point. So we're going to plug that point in, negative 4 for x and negative 4 for y, and negative 2 for x. So I'm just going to fill everything else in that I had, and then the a, and then the equals. And then simplify it from there. So negative 4 is equal to a times 1 times negative 4, which just gives me that a is 1. So in intercept form, it's going to be y equals 1, x plus 3, x minus 2. And of course, I could just drop that 1 out. Now, if I wanted to do it in standard form, which by the way, on the quiz, I just have you keep it in intercept form. But if I wanted to do it in standard form, I would just FOIL that out. Y equals x squared plus x minus 6. Just to show that that's the same equation. But on the quiz, we'll leave it in intercept form. Trying another one here, I see the roots of negative 1 and 4. So y equals a, x plus 1, x minus 4. I'm going to take the ordered pair of my point, 3, 2, substitute 2 for y and 3 for x, equals a, x plus 1, x minus 4, and then just solve this from here. So a times 4 times negative 1. If I solve that is a equals negative 1/2. And I'm just going to leave this one in intercept form. Negative 1/2, x plus 1, x minus 4. No need to FOIL. Done and done. Intercept form. Okay, so now we're going to use vertex form, given a vertex and a point. So this won't surprise you. So this is, we're going to use the y equals a x minus h squared plus k. So this was moved right 1 and down 2. Similarly to the last time, we're going to take the ordered pair and plug it in 2 for y and 3 for x. And then we're going to solve for a. So 2 equals here, 3 minus 1 is 2 squared, which is 4a minus 2. And so nicely, a is 1. So it's going to be y equals 1 x minus 1 squared minus 2. And we're just going to leave that. I'm not going to have you do it in standard form. Same process here, no picture, but I know the vertex here is negative 3, so that's x plus 3 squared plus 3. Take my point, substitute in negative 1 for y and 1 for x. And the colors help me, don't they? So it's negative 1 equals 4a is 16a plus 3. So negative 4 is 16a. So a here, negative 1/4. Right. And then I would just put that back together. So negative 1/4 times x plus 3 squared plus 3. And no need to FOIL that out or anything. All right, so all is well and good, right, until we get to the last one. Bum, bum, bum. So the last one is going to use standard form, and it's going to use 3 points. So we weren't given any special points. We weren't given a vertex or a root. We were just given 3 random points. So we're going to substitute in for y and for x 3 times. So if the first point is negative 1, 3, the 3 is y equals a times negative 1 squared plus b times negative 1 plus c. Or if I clean that up, a plus b plus c equals 3. You're plugging the points into x and y. The next one here, 0, negative 4, thankful for a 0, equals a times 0 squared plus b times 0 plus c. So this one is just c equals negative 4. That's going to be helpful. The last one, 2, 6. 6 equals a times 2 squared plus b times 2 plus c. So 4a plus 2b plus c equals 6. Does this remind you of anything? La la la, it is a 3x3 system. Yay, 3x3 system. Remember those? Thought they were never going to come back, right? This 3x3 system is back. But this is an easy one. Why is it an easy one? Right, because we already know the c is negative 4. What should we do with that negative 4? Right, we should plug it in. So I'm going to get a plus b, if I clean it up a little bit, is going to equal 7. Although I feel like, yeah, you know what? I did make a mistake there. This should be a minus b, right? Because it was negative 1. Ooh, good catch. A minus b. And then this one is going to be, let's see, 4a plus 2b minus 4 equals 6, which is 4a plus 2b is 10, which can't I, like, simplify that? Right? To make it 2a plus b is 5. And so that I can, like, really help me out. 2a plus b is 5. That's going to make my life pretty easy, right? 3a is 12, so a is 4. And if I plug back in, I'm going to get that b is negative 3. And now here's the thing, you got to put it all back together. So the y is equal to ax squared plus bx plus c. And I'm putting those a, b, and c's right in there. You do have one 3x3 question on the test. So here we are writing quadratic equations on the quiz. I should have said quiz, on the quiz.